in terms of its orbit, such that at this point right here, which is 20,356 kilometers exactly out from the Earth, if you orbit at that distance, you will orbit the Earth exactly once every 12 hours. All right? There are 24 GPS satellites that are arrayed in overlapping orbits that have a precision to within about, not joking, a few inches of where their orbits are. They're constantly measuring and self-correcting that using inertial guidance. I would say they were using GPS, but that wouldn't make any sense. All right? Now, here's an interesting fact. GPS was put up in the early 1970s, is when it started, basically. All right? And was a military-only application. So you know how, like, many of you have, like, a GPS thing that you use in your car or whatever, or something, or your family does or whatever. Everyone's familiar, right? All right, those are accurate to about 10 meters of space on the planet. And the way they do that is by looking for as many of those 24 satellites. The most you can catch at any given time is 12. All right, most of the time you're only going to catch 11 to 10. 9's a good signal, but using as 3, you can find your location anywhere on Earth with different levels of accuracy. All right, your little handmade GPS unit only works to about 10 meters of accuracy, which is still pretty amazing. That means that it can definitively pinpoint me as being in this room and nowhere else. All right. GPS, though, is accurate to almost half a meter of space, all right, on the planet. But you're not allowed to use it for that much because it's owned by the federal government. It's a defense asset. And it sends out radio signals at a regular speed. Each satellite has its own radio signal that it sends, all right? It was not available to anyone until the 1980s when a Korean airliner drifted off course, accidentally into Soviet airspace, and got shot down. At which point then President Reagan turned on GPS basically for civilian use. He said, we have this really cool thing that can tell anyone down to 10 meters where they are on the planet. Maybe we should let people use that, considering that we spent all the money on it already. The newer systems, that would be the Russian and particularly the European systems, are more than 3 times as accurate as the United States. Some of them arguably can get you down to a position within 6 inches to 1 foot of where you are, with more than 99% accuracy on the face of the Earth, which itself, if you think about it, is pretty incredible. Now, if you think about that, this is how far out this is. Double it then. And I don't have space for this on my slide. All right? And you'll get out to about here, basically, in terms of distance from the Earth. And you've now reached, still in medium Earth orbit, all right? But you've reached the line between medium Earth orbit and far Earth orbit, all right? Or high Earth orbit. People call it different. There's like actually several different names and disagreement over what it should be called. That line, all right, has a very unique feature. And that is if you put something in orbit right there, it is now at, all right, geostationary orbit is what it's called. And that means that if you park it here, it will stay there over whatever spot on the Earth it is. It will stay there and not orbit the Earth. It will stay exactly where it is in terms of reference to its location over the Earth's surface. This area out here, interestingly enough, is by far where most satellites are. Why would it be useful to be able to park yourself out here and never move? So there, let's say there's a satellite that if we went straight up into the air, all the way out, it's there and it's always there.
Constant surveillance?
Pardon?
Constant surveillance?
Constant surveillance, although most surveillance satellites are actually much closer in because you don't get a very good view from all the way out here. Any other ideas?
I think to be exclusive in that one spot.
It's good to have something in just like one spot, yeah?
I want really fast communication. That's all we need to do.
Communication satellites all park themselves out here, all right? So XM, like satellite radio, DirecTV has 13 satellites positioned in particular locations. Now, if you have a bunch of people that you want to contact the same satellite, all right, then it kind of helps to be able to say, this is where that satellite will always be, no matter what, over this particular spot on the Earth. So if I'm setting up my satellite dish at home, not that I can because our apartment's on the wrong side of our building, and as a result we have to pay usurious rates for cable. Not that I care. I live for an NFL Sunday ticket and I can't have it anymore. But it helps to be able to say, this satellite's always there. So when you go, how many of you ever set up a satellite dish for like DirecTV or anything?
Nope.
You like punch in where you are And the thing sits around and it figures out, and it's like, oh, hey, point your dish in exactly this direction and you'll probably catch a satellite. And sure enough, you do. All right? So if you've got a satellite dish, it kind of helps to know where the satellite's going to be. And unless you're going to be constantly calling in and looking for the satellite and having a very extensive network of other satellites to communicate, you need to use geostationary orbit. You need to always have your satellites over the same spot. With GPS, on the other hand, it's useful to have it in what is it called? Semi-synchronous. All right. Oh, the other name for geospatial is geosynchronous orbit as well. Good morning. So anyway, those are your three main orbital altitudes. All right. It's real crowded close. Halfway through is GPS satellites, and nothing else is allowed there. All right. Only GPS satellites because of the immense precision that you need. And then there's geostationary / geospatial orbit, which is for things that you need to position, which is actually the most, it's not crowded, it's the busiest, you could argue, or something, because it has the most stuff, but there's a lot more space as you get farther out. Yeah?
Where's the Earth's mesosphere?
Funny, we were just about to get to that. The Earth's mesosphere, you see the second line in self-propelled aircraft? You're talking about 35, it starts right about there, and it ends right about there. All right? So the rest of this beyond the Earth's mesosphere. All right? Like, you see the sort of blue ring around the Earth on the edge there? And I had to crop this photo to fit it. It's actually, like, massive. If I was going to project it up here, it would go well beyond the wall. The moon's somewhere about, like, twice as far over there. But that should kind of give you a sense for how far out some of these satellites. You think they're all like, you'd want them as close as possible? No, there's some really good reasons to actually have them far away because of the unique properties. Remember, the farther you get in, the faster you start to spin along with the Earth's rotation and the gravitational pull of the Earth. And it makes sense like a figure skater, right? How many of you like watch the Olympic figure skating or anything? They put their arms out, they spin slow, and then as they bring their arms in, they start to go faster and faster. Well, satellites work the same way. Just think figure skaters, and you'll get it. Okay, so enough about satellites and all of the stupid stuff I researched. Here's the big question. Is it topical? All right, and I think this is going to be one of the major debates. If you can win that it's T, all right, I would seriously consider reading an affirmative that had something to do with global positioning satellite technology, all right, and doing something to prevent interference on them right now. There's a bunch of new technologies, right? Everybody's got a 3G phone now, pretty much, right? There are 4G phones that are coming out. Those are LTE networks, and like Verizon's really pimping theirs right now, and Sprint likes to brag about it and everything. Slight problem with some of these. They seem to be having some interference effects with GPS. All right? Which is not good, since that's the only way that airplanes know where they are anymore now, and stuff like that. It's the main way we get around this planet. Yeah?
If like the Russian version of GPS is better, why don't we use that version?
Because we're kind of just... Yeah, basically. Better dead than red, man.
Because like, because both of them work like universally over the whole Earth. So.
Well, they have to or they don't,
yeah.
right? You know. And that's one of the reasons that Europe and Russia launched. Russia launched theirs a while ago after we launched the GPS, because like during the Cold War, it's like one of those things where it's just like if either of us had one, the other side had to have the same thing. You know, if we launched like an elaborate network of geosynchronous orbiting McDonald's, they'd have built one too. You know, it's just like we had to. It's like having like a little brother or something, you know. And it's obviously pretty useful when you're trying to nuke someone too. It helps to have a system of satellites that can very precisely guide things. Which is why sitting up near almost every GPS satellite out in the Earth is, next to every Russian one is a United States satellite, keeping an eye on it, figuring out what's going on, and depending on who you ask, arguably on the ready to shoot it down should war ever break out. Anyway, is it T? Huh? Haven't got a day set yet. We're going to get there. Okay, can you at least read the bold stuff? Anyway, this is the T. You have this file already. This is the T file that the lab that I have recently again begun leading put out. Thanks, Sarah, for this. This one's pretty good. Some of these cards are like shocking me at how precise they are. First, the mesosphere. 31 to 50 miles, i.e. 17 to 80 kilometers, roughly, above the Earth's surface. That doesn't make any sense, actually. That's 17. We need to check that card, by the way. Well, 30 miles would not be 17 kilometers.
It's the Weather Channel, man.
Yeah. Anyway, 80 kilometers is the number that matters, actually. That's where the mesosphere ends.
I don't do math.
Yeah, all right. That number's right, though, so we'll stick with that. And we're soon for an updated Z file. I might have just copied it over wrong. Beyond, on the far side of, so we got to go beyond, we got to be on the far side of this mesosphere. Now here's the important, of space. The Outer Space Treaty speaks of exploration of outer space. This wording could be interpreted to mean that space must be the object of the exploration. And this gets back to the, what's the difference between Hubble and other types of satellites distinction. So if we're exploring Earth beyond, right, excuse me, exploring space beyond the Earth's mesosphere, then the question is what is exploration and or development, and where does it have to be? All right? Is it topical in that sense? So let's go through and ask ourselves some questions, right? First of all, how do we determine beyond the Earth's mesosphere? Is it a question of where we're looking, or where we're looking from, what we're looking at? Those sorts of questions? Somebody, what do you think? Let's toss out to the peanut gallery here. Y'all have been pretty chatty so far. And done. Thank you very much. I seem to have settled this question entirely. Seriously, how do we figure it out? Do satellites count? Are they T?
Would be developed.
You're looking towards space.
If we're looking towards space, I think we can rather comfortably say that is space exploration, and that's aside from the are there people in it, and pardon by the parlance here, but most of the cards say this, the manned versus unmanned. I don't know, I think it's found like a good gender neutral substitute for the person. I feel, that there's got to be an actual substitute, but yeah.
What about development?
Development. Is that developing space?
Yes, development in space.
Developing in space. That's the development of space, is it not?
Well, do you have a definition for development?
Huh?
Do you have a card for development?
Check the C file.
Yeah.
Yeah, we have good ones.
Yeah.
Yeah, we got all sorts of good ones.
Yeah, exactly. Boom. Right. Development. Is it development in or of space? So.
What is space?
Huh?
The space in between?
Oh, good Lord. Okay, let's not get
That's all it is. That's the important word.
Yeah, beyond the Earth's mesosphere. Beyond, I think, is actually the word that matters. Anyway, so let's go through bit by bit. Observation satellites, spy satellites. Is that? We're going to stick. So, is it exploration beyond the Earth's mesosphere? What are spy satellites exploring? The Earth. So, is that exploration beyond the Earth's mesosphere? Maybe. Let's just say no for now, just for the sake of making this end faster for you. All right? Communication. Oh, but development. Is that development beyond the Earth's mesosphere?
Yes.
It's already there.
Are you? Well, suppose you put new ones
You
up.
increase something.
Yeah, all right. Yeah, there's an increase.
That wouldn't be a plan if you're just planning to keep them there.
Yeah, well, substantial with regard to what, though? It's a substantial increase, right? And an increase over what? What's your baseline? How do you know? Good question. If you built some cool new ones where they were like way better, right?
Yes.
Okay. Communication satellites. Seems like, are those even exploring anything? Maybe not. Are they developing, though? If you put up a new communication satellite network, maybe. Next, navigation satellites. Probably development again. Is it exploration? Probably no. Sense a recurring theme here, people. All right, weather satellites, maybe not. Don't know. Again, development maybe, exploration no. Research satellites though. There we go. Now we're doing a little bit better on this exploration question and once again the development question. All right? Whether or not it's topical under exploration or development is an important thing. And then when we get to like the 5 files I think you ought to have for considering satellites, I'll cover what I think you sort of need to be packing on some of these different questions for pretty much every debate round. Part 3 now. Now we're getting on to the meat of the issue. Is it a good idea? All right? So, that's really the big question we're asking. Debate, should we or shouldn't we do something? This